Now, this is a simulation application, and we are going to be talking about queuing problem and port of New Orleans. And this port, as you know, is very busy and it's costly for any barge to wait for unloading the cargoes to the port. And it's going to be a problem, and the port need to make a decision about how many delays are happening and what capacity they need to run, and they need to hire more people, or how to arrange things better. So that is the question. So as you can see here, fully loaded barges arrive at night for unloading. So for efficiency, they are doing work at night, and this unloading has to happen at night. And the number of barges each night varies from 0 to 5, and the number of barges vary from day to day. So, per night, it could be zero, nothing sometime, but to 5 barges they can come on night. Or it will just vary day to day. Maybe Wednesday they might have more, and Sunday they might have less. The supervisor has information which can be used to create a probability distribution for the daily unloading rate. From the previous data, they have this unloading data and how many barges are arriving. For example, 13% of chance they have when no barge arrives per night, and sometimes 17% of chances, 25 chances of having 3 barges per night, and 20% for 4 barges coming, and so forth. This is available from their historic data, say last 6 years, 6 months data, or a year's data. And barges are unloaded first in, first out basis. So, they have to respect the priority that they get. And here is a unloading rate. Daily unloading rate of 1 happens at a probability of 5%. At 50%, they are able to handle 3 barges unloading every day. And barge 4 and 5 and so forth, this data is also available. This is related to their capacity. The dock superintendent wants to do a simulation study to enable him to make better staffing decisions. What they want to do is, how many people they need to hire more, that they need to understand, and for that they want to conduct a simulation so that they may understand what kind of delays they are facing every day. So let's follow these 5 steps of simulation. The first one is establish probability distribution. Thankfully, this is already done for us by the manager. So arrival is 0 to 5, and the probability is given as 0.13 or 13% to 10%. And if you add them up, it's going to be a 10%. So barge arrival data is available. Also remember that we have unloading data as well. So unloading rates data, daily rates, 1 to 4 barges they are able to unload, and the probability is 5% chance of not doing anything. Maybe that night, all the machine broke down or something like that. So they were not able to um, unload anything. 15% of chances to do only 1 barge unloading for, I don't know, it could be a labor problem, it could be machine problem, it could be the environment. It rained too hard, or it was so harsh weather at the night. So that could vary. Sometimes you could, unload 4 barges because for some reason, you were able to hire more people and therefore were able to unload this many barges. So that unloading rates are available. And then we have step 2, build a cumulative probability distribution. So what we do is just we add one more line, one more column, which is cumulative probability, as we learned last time. It's simply the first one is just simply the same thing, 13%, but the next one is going to be add not only your pertaining probability, but also the previous probability together, and that gives you 30%. And the next one, 15% plus the previous cumulative probability, and it gives you everything. And the last step, if you add them together, it's going to be 100%. And you do the same for unloading rates data, and I added cumulative data, and this is how it is given. Then third step is setting random number intervals. So we need to find, how many probability we are going to create for random numbers. So for that, what we do is, you paste this one and then create random number intervals, which is this. It's just simply multiplying cumulative probability by 100. That's what it is. So 13 instead of 0.13 you have, instead of 0.3 you have 30, and so forth. And when you are adding that here in the first column, what you do is you copy 13 to 90, so exclude 100, right? And then copy on the second row like this. You have to paste the value, not just paste values, right? And then you have to add 0 here, right? So because we are starting from 0 to say 12 and 13 to 29. So we have to add 0 here, and then you have random number intervals. The same thing I did here, I multiplied by 100 for unloading rates data, and I have 5 to 100. I paste 5 to 90 over here and added a 0 here. So I have unloading rates data too. If you have done that, now you are ready on step 4, where you are going to generate random numbers. So here we have to set up the simulation spreadsheet first. So first column I put the number of days. So let's say we are simulating for the first 15 days only. Then we have 1 to 15. Of course, you can simulate 1 to 365. So your simulation, the more the better. But for the demonstrating purpose, I just add 15 days here. And the second column is number delayed from previous day. We don't have at this moment the data about how many delays happened before, because it's day 1. So we can simply start with 0. And then we have to create a random number to create number from nightly arrival, barge arrivals. So here I'm going to create just a random number using rand function, right, that we have used before. And I'm going to multiply by 100 so that it's going to be a 100 numbers. So 41 is my rand number, and then I'm going to just copy that down. So 58, 17, and so forth, I have random number created. And then I have to find the number from nightly arrival, and this is going to be a VLOOKUP function that we used before. So I'm going to just VLOOKUP of this number from number of arrivals and comma, and from these first two columns, I want to bring the second column value, meaning that 58 look up that value from these categories, and 58 falls into between 45 and 70, so it should be 3, and you pick up that value there. And this is approximate match, it's not exact match, so you have to do, it is approximate match, so you type true, then it says yes, it's 14, so 14 is between 13 and 30, so the number of arrival is 1, so that you are able to look at that here. And then, as I said before, you want to make the table on absolute reference, so therefore you add $ before columns and rows. If you have done that, you can just copy that down, and we'll do this a little bit later. So at this moment, we have this number of from nightly arrivals. Then we have total to be unloaded, right? So this is going to be the delays plus and number from nightly arrivals, right? So we have previous undone barge, unloaded barge, and we have to take care of that. And then we have newly arrived barge, and both of them we have to take care of. So you just add them up. That's a total to be unloaded. Now, for random number, we have to create a number unloaded, how many of them you are able to unload, and that has to be created here. And we want to use random function again to make it simulated to use random numbers. So if you double click on that, it's going to copy the formula right away. And it's down there. And actually, I have to multiply by 100. I forgot. And again, double click on it. It'll copy the formula. And there was um, total unloaded, right? So this is total unloaded. Okay, and then number unloaded is going to be the thing that you are able to unload with your capacity and people and weather and so forth. So you want to look up, VLOOKUP this value from the unload rates data from here, right? And then you want to bring the second column value, and this is approximate match, so it's going to be true. Hit enter. So 98, 98 is above 90, so 4 of them you are able to unload, which is really good. So you just need to add $sign to make it absolute reference, and then copy that down to here. Then you have the number unloaded. So here is 0, it's 1.319, so 1.319 is between 0 and 5, so therefore 0 is there. Sometimes, the weather was not good and so forth. For that reason, you're not able to unload at all. And then the rest of them is just a calculation. For example, number delayed from previous day equals total to be unloaded, right? Minus number unloaded, right? So you have total number of unloaded and then number unloaded, and so 3 to 3, so that is 0. That's very good. And to be unloaded is again unloaded one, previous one plus newly arrived one here, and that's given here. So you can just copy these formulas, then you will have your simulation over here, right? So now you have number delayed from previous day. So it's increasingly you have more delays, and here total to be unloaded is also increasing in this scenario. And let's see the total delays here equals how many delays have you had for 15 days. You had 71 delays in this case. Total arrival, so you can copy this formula and then paste it. And total night arrival 38, and total unloaded was 31, right? So that's your function. However, after completing your simulation, you need to examine if this is making sense or not, right? For example, right now you have -1, right? Number delayed from previous day. Can you have negative number in real life? I said no, right? There's no negative person, so there's no negative unloading. So something is not right, and we need to rectify this situation. And how do we do this, right? So first of all, this one cannot be negative, so this one has to be fixed. So I want to say if I want to use a function if L7 minus N37 is less than 0, then what? Then just 0, right? So there's no negative, but yeah, nothing happened. Um, so no delays happened. So that's what it means. However, if it's greater than 0 or equal to 0, then just write down L37 minus N37, right? So that has to be the function, and you use that, and then it fixes that. So let me do this again. Actually, let me um, let me use the previous function. Okay, so let me just copy this so that you have a clear idea of what I am doing. So go here, and I'm gonna paste it here. So I'm gonna leave this one there, and then use the function. For example, this is -1, and I'm gonna use if function. If n56 and n56 is less than 0, then it should be 0. Otherwise, bring the value as it is. So I only use this function. So instead of negative, you have 0, and scroll that down so that you can have the function there. Right. So now it's negative disappeared, and you have only positive numbers and there. So look at this situation. Total to be unloaded is 0 on this day 3, and the number unloaded is 4. So this is not right because you have nothing to unload. However, random number created 99. As a result, the number unloaded is 4. And this number itself is right, however, it does not make sense because nothing to be unloaded you had, although you had the capacity to unload the things. So in this case, this simulation is wrong, and you need to fix that simulation. So what you can do is, you have to look at if function and say, yeah, if this is 0, right? If total to be unloaded is 0, then just give me 0. And if not, if it's positive or if it's not 0, then use this VLOOKUP function to find the values, right? So that's and that makes sense. So I want to do that, and you have to add one more $ there here. So that's good, and I'm going to put it up, and formula will be copied everywhere, right? So that has been done, right? So now um, the simulation is working much better than before. So now you know that your simulation is working better than before. So to to compare their performance, let me copy this, and then what I'm going to do is I'm going to say paste here, paste special, and paste. And I want to just fix these random numbers. So let's create one more time. Okay, so I wanted to have this negative number and see what happens. So initial forecasting had negative numbers, and it needs to be fixed, and I tried to fix it, and I just want to know if that is working. So I'm gonna just highlight and press command or control for if you are using Mac, and then right click, copy, and then paste, right? Paste it, paste special in the same place as a value. Maybe I cannot do that. Maybe copy and then paste special and values. Very good. And then this part, I'm going to copy and paste values. Good. And I'm going to do the same thing because I want to compare these two simulations, whether they are doing right or not. Okay, now I have done that. So we are doing the same numbers. And as you can see, if you compare the first simulation, I did not, change things. However, the second one, I, used the VLOOKUP function to find which one is when to use zero and when not to use zero. So those things were done there. If this function, if it's less than zero, it should be zero. And then this function I used. As a result, if you can see, no negative number is there. If the negative happens, then it should be zero. And total to be unnoticed, we have two zeros here. And at that time, still number unnoticed was 1 and 1, and this causes some problem. And look at here, if it was 0, although it's 53, we have 0 here. So in this way, you are able to automatically fix the problem and your simulation is now more reliable and you can work with this simulation more than before. So again, once you finish your simulation, you have to do this examination and then fix it as you can as best as you can so that your simulation is not leading you to some other conclusions that you did not want to make, but the right conclusion. Okay, thank you.